So we finished our conversation with VLDLs, enough to say as VLDLs mature after their interaction with lipoprotein lipase to IDLs, they can be further metabolized to LDLs, predominantly by, at this point, the LDL is laden with cholesterol. So the LDL has two fates. It can either be taken up by extrahepatic tissues or be taken up by the liver. So the uptake of the LDL by cells is illustrated here, and it involves an interaction with the ApoB100 on the LDL and the LDL receptor found on the cell membrane. And these receptors, denoted here, are found within these clathrin-coated pits on the cell surface. So this receptor-ligand interaction on the plasma membrane allows for the invagination of this endocytic vesicle, which includes this LDL particle. The vesicles then fuse through a series of reactions with the lysosome, and within the lysosome, the acidic subcellular vesicles contain several degradative enzymes. This allows for the metabolism and freeing of the cholesterol, which will then contribute to our unesterified cholesterol pool within the cell. We know from previous discussions that this unesterified pool has several fates, first of which being esterification by ACAT to form cholesterol esters. Second, the unesterified pool can be transferred to HDL using our transporters ABCA1 and ABCG1, and HDLs can return this cholesterol back to the liver. So this is the predominant pathway by uptake of LDL can then contribute to an elevation of the pool of cholesterol within the cell. So you'll notice here that there's several key regulations that this pool can then influence. The first being downregulation of the receptor synthesis. So a decrease in the LDL receptor on the cell surface will then decrease LDL uptake. We also know that this pool of cholesterol can inhibit cholesterol synthesis, and it does this through several manners. Remember, increased cholesterol can target HMG-CoA reductase for degradation, as well as inhibit the transcription of HMG-CoA reductase itself. So the regulation of the LDL receptor itself can be regulated in two primary manners. The first being degradation. So the uptake of LDL by these endocytic vesicles allows for recycling of the receptors, shown here, back to the cell surface. So PSK9 can increase receptor degradation, thereby reducing the number of receptors that are recycled back to the cell surface. The LDL receptor can also be regulated transcriptionally, and this is through inhibition of the same transcription factor we saw that regulated HMG-CoA reductase, and again, that's the sterile response element binding protein. So as cholesterol comes into the cell by LDL uptake, again, it increases this unesterified cholesterol pool. And high levels of cholesterol will inhibit the transcription factor, sterile response element binding protein. And by inhibiting that transcription factor, it's not available to increase transcription of either the LDL receptor or HMG-CoA reductase. So to this figure here, we've added on the role of LDL in influencing the pool of cholesterol within tissues. So again, LDL can be taken up by peripheral tissues and will influence the intracellular pools of cholesterol here, and it will also influence the synthesis of cholesterol. And it will do so in extrahepatic tissues as well as in the liver. So let's finish with this question to connect the material from this week to the previous week. So a 45-year-old man is found to have elevated serum cholesterol, 300 mg per deciliter, so this is a significant elevation. And we're asking which of the following lipoproteins would be the largest contributors to the measurement of plasma cholesterol. So is it going to be chylomicron remnants and VLDLs? So we know that chylomicron remnants are a maturation product of chylomicrons and have some triacylglycerol and some cholesterol and cholesterol ester, but they're not predominantly composed of cholesterol, and neither are VLDLs. These are going to be characteristic of a high level of triacylglycerols. The same is true here for chylomicrons and VLDLs. Remember, the major distinguishing factor between the two is chylomicrons are carrying dietary lipids, whereas VLDLs are carrying lipids that are synthesized de novo in the liver. Next, we have HDL and LDL. So from previous conversations, we know that HDLs contain cholesterol from cholesterol efflux from peripheral tissues back to the liver. So these predominantly carry cholesterol and cholesterol ester. The same is true from LDLs, which again are a maturation product from VLDLs and predominantly carry cholesterol and cholesterol ester. So C looks like a good choice here. And finally, LDLs and adipocyte lipid droplets. So the adipocyte lipid droplets are going to be retained within the cell and wouldn't be in circulation to begin with. These would also carry high levels of triacylglycerol, as adipocytes primarily store our triacylglycerols. So this leaves us with C, and this is going to be our major contributing lipoproteins to total cholesterol measurements clinically. We have one final piece this week to look at other roles of cholesterol within the cell, and then we'll be finished with Unit 3.